Astrophysicist announces her discovery that could rewrite story of how galaxies die at the annual meeting of the American Astronomical Society in St. Louis, Missouri. Allison Kirkpatrick, assistant professor of physics and astronomy at the University of Kansas, will announce her discovery of cold quasars, galaxies featuring an abundance of cold gas that still can produce new stars despite having a quasar at the center, a breakthrough finding that overturns assumptions about the maturation of galaxies and may represent a phase of every galaxy's life cycle that was unknown until now. Her news briefing, entitled "A New Population of Cold Quasars," takes place Wednesday, June 12. A quasar, or quasi-stellar radio source, is essentially a supermassive black hole on steroids. Gas falling toward a quasar at the center of a galaxy forms an accretion disk which can cast off a mind-boggling amount of electromagnetic energy, often featuring luminosity hundreds of times greater than a typical galaxy. Typically, formation of a quasar is akin to galactic retirement, and it's long been thought to signal an end to a galaxy's ability to produce new stars. All the gas that is accreting on the black hole is being heated and giving off X-rays, Kirkpatrick said. The wavelength of light that you give off directly corresponds to how hot you are. For example, you and I give off infrared light. But something that's giving off X-rays is one of the hottest things in the universe. This gas starts accreting onto the black hole and starts moving at relativistic speeds. You also have a magnetic field around this gas, and it can get twisted up. In the same way that you get solar flares, you can have jets of material go up through these magnetic field lines and be shot away from the black hole. These jets essentially choke off the gas supply of the galaxy, so no more gas can fall onto the galaxy and form new stars. After a galaxy has stopped forming stars, we say it's a passive dead galaxy. But in Kirkpatrick's survey, about 10% of galaxies hosting accreting supermassive black holes had a supply of cold gas remaining after entering this phase, and still made new stars. That in itself is surprising, she said. This whole population is a whole bunch of different objects. Some of the galaxies have very obvious merger signatures, some of them look a lot like the Milky Way and have very obvious spiral arms. Some of them are very compact. From this diverse population, we then have a further 10% that is really unique and unexpected. These are very compact, blue, luminous sources. They look exactly like you would expect a supermassive black hole to look in the end stages after it has quenched all of the star formation in a galaxy. This is evolving into a passive elliptical galaxy, yet we have found a lot of cold gas in these as well. These are the population that I'm calling cold quasars. The astrophysicist suspected that cold quasars, in her survey, represented a brief period yet to be recognized in the end phases of a galaxy's lifespan. In terms of a human life, the fleeting, cold quasar phase may something akin to a galaxy's retirement party. These galaxies are rare because they're in a transition phase. We've caught them right before star formation in the galaxy is quenched, and this transition period should be very short, she said. Kirkpatrick first identified the objects of interest in an area of the Sloan Digital Sky Survey, the most detailed digital map of the universe available. In an area dubbed Stripe 82, Kirkpatrick and her colleagues were able to visually identify quasars. Then we went over this area with the XMM Newton telescope and surveyed it in the X-ray, she said. X-rays are the key signature of growing black holes. From there, we surveyed it with the Herschel Space Telescope, a far-infrared telescope, which can detect dust and gas in the host galaxy. We selected the galaxies that we could find in both the X-ray and in the infrared. The researcher said her findings give scientists new understanding and detail of how the quenching of star formation in galaxies proceeds, and overturns presumptions about quasars. We already knew quasars go through a dust-obscured phase, Kirkpatrick said. We knew they go through a heavily shrouded phase where dust is surrounding the supermassive black hole. We call that the red quasar phase. But now, we've found this unique transition regime that we didn't know before. Before, if you told someone you had found a luminous quasar that had a blue optical color, but it still had a lot of dust and gas in it, and a lot of star formation, people would say, no, that's not the way these things should look. Next, Kirkpatrick hopes to determine if the cold quasar phase happens to a specific class of galaxies or every galaxy. We thought the way these things proceed was you have a growing black hole, it's enshrouded by dust and gas, it begins to blow that material out, she said. Then it becomes a luminous blue object. We assumed when it blew out its own gas, it would blow out its host gas as well. But it seems with these objects, that's not the case. These have blown out their own dust, so we see it as a blue object, but they haven't yet blown out all of the dust and gas in the host galaxies. This is a transition phase, let's say of 10 million years. In universal timescales, that's really short, and it's hard to catch this thing. We're doing what we call a blind survey to find objects we weren't looking for. And by finding these objects, yes, it could imply that this happens to every galaxy. Subaru telescope captures 1,800 exploding stars by combining one of the world's most powerful digital cameras and a telescope capable of capturing a wider shot of the night sky compared to other big telescopes. A team of researchers from Japan have been able to identify about 1,800 new supernovae, including 58 Type Ia supernovae 8 billion light-years away, reports a new study released online on the 30th of May. A supernova is the name given to an exploding star that has reached the end of its life. The star often becomes as bright as its host galaxy, shining 1 billion times brighter than the Sun for any time between a month to 6 months before dimming down. Supernova classed as Type Ia are useful because their constant maximum brightness allows researchers to calculate how far the star is from Earth. This is particularly useful for researchers who want to measure the expansion of the universe. In recent years, researchers began reporting a new type of supernovae 5 to 10 times brighter than Type Ia supernovae. Named superluminous supernovae, many have been trying to learn more about these stars. Their unusual brightness enables researchers to spot stars in the farthest parts of the universe usually too faint to observe. Since distant universe means the early universe, studying this kind of star could reveal characteristics about the first, massive stars created after the Big Bang. But supernovae are rare events, and there are only a handful of telescopes in the world capable of capturing sharp images of distant stars. In order to maximize the chances of observing a supernova, a team led by Kavli Institute for the Physics and Mathematics of the Universe Kavli IPMU, Professor Naoki Yasuda, and researchers from Tohoku University, Konan University, the National Astronomical Observatory of Japan, School of Science, the University of Tokyo, and Kyoto University, used the Subaru telescope. This telescope is capable of generating shape stellar images, and the Hypersuprime-Cam, an 870-megapixel digital camera attached at its top, captures a very wide area of the night sky in one shot. By taking repeated images of the same area of night sky over a 6-month period, the researchers could identify new supernovae by looking for stars that suddenly appeared brighter before gradually fading out. As a result, the team identified 5 superluminous supernovae, and about 400 Type Ia supernovae. 58 of these Type Ia supernovae were located more than 8 billion light-years away from Earth. In comparison, it took researchers using the Hubble Space Telescope about 10 years to discover a total of 50 supernovae located more than 8 billion light-years away from Earth. The Subaru telescope and Hypersuprime-Cam have already helped researchers create a 3D map of dark matter, an observation of primordial black holes, but now this result proves that this instrument has a very high capability finding supernovae very, very far away from Earth. I want to thank all of my collaborators for their time and effort, and look forward to analyzing our data to see what kind of picture of the universe it holds, said Yasuda. The next step will be to use the data to calculate a more accurate expansion of the universe, and to study how dark energy has changed over time.